Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoy, your teacher of physics. Today we are going to look at reflection of light at curved surfaces, and this is physics lesson for learners in S.2. So now let's look at what curved surfaces are. So when we talk about curved surfaces, we mean specifically the curved mirrors. So these curved mirrors are always cut from surfaces of spherical objects. So now these curved surfaces are mirrors from spherical surfaces. So now what do we mean by spherical surfaces? If we have a surface in this shape, so a surface in this shape is a spherical surface. Now a curved mirror can be obtained from this surface if we cut part of it. For example, if we cut this surface at this point, then we take this section. So we shall find that the surface which is going to be formed is this. That is after cutting the spherical surface. And the type of mirror that we shall obtain from this surface will depend on which part of the surface is silvered or which part of the surface is shiny. So now we have types of curved surfaces. Types of curved surfaces. Types of curved surfaces. And we say the curved surfaces are the curved mirrors. So we are looking at the curved mirrors. Now, what are the types of the curved mirrors that we have? There are mainly two types of curved mirrors. One is the concave mirror. Concave mirror. And concave mirror can also be called a converging mirror. Converging mirror. Then the second type of curved mirrors is the convex mirror. Convex mirror. And a convex mirror can also be called a diverging mirror. So dear learners, these are the two types of curved mirrors. One is the concave mirror, and a concave mirror is also called the converging mirror. Then the second one is called the convex mirror. Its other name is diverging mirror. So dear learners, we are going to look at these two types of curved mirrors one by one, and we are beginning with the concave mirror. Concave mirror. Now dear learners, what is a concave mirror? So this is a type of mirror in which the inner surface is silvered. That is the inner surface of the sphere from which this mirror has been cut. So this is a type of mirror in which the inner surface is silvered. Surface is silvered. The inner surface being silvered means the inner surface is shiny. It is the reflecting part of the mirror. Dear learners, this is how a concave mirror looks like. It is curved in shape. Then the side which is silvered is the inner surface, which means reflection takes place in the inner part of this mirror. This is the silvered surface. Silvered surface. So the surface being silvered means it is shiny, which means when rays fall on the surface, the rays are going to be reflected. Now we said a concave mirror can also be called a converging mirror. You may be asked, why is a concave mirror called a converging mirror? The reason is because rays parallel and close to the principal axis will converge to a point which is called the principal focus after reflection from the mirror. So you say it is also called a converging mirror. Converging mirror because rays that are close and parallel to the principal axis converge to a point called the principal focus. Focus after reflection from the mirror. So dear learners, you can be asked, why is a concave mirror called a converging mirror? The reason is because all rays that are close and parallel to the principal axis converge to a point called the principal focus after reflection from the mirror. To converge means to come and meet at a certain point, that is after reflection from the mirror. So this is what we understand by concave mirror. So dear learners, let's also look at the second type of the curved mirrors, which is called the convex mirror. Convex mirror. So now, what is a convex mirror? A convex mirror is a type of a curved mirror in which the outer surface is silvered, which means the reflecting surface of a convex mirror is the outer surface. It is that surface that is polished. It is highly silvered, meaning it is shiny. So now this is a type of curved mirror in which the outer surface is silvered, meaning the outer surface is made shiny. So now dear learners, this is how a convex mirror appears. So the reflecting surface is the outer surface. So this is the silvered surface. So now these surfaces, the reflecting surface or the silver surface, will depend on the surface of the sphere from which these plane mirrors are cut. If the sphere has the reflecting surface, which is the outer part, then the type of mirror that is formed is called the convex mirror. Then if the sphere has a surface which is silvered in the inner part, then the type of mirror that will be formed is called the concave mirror. So now we said convex mirror is also called a diverging mirror. So dear learners, you can be asked, why is a convex mirror called a diverging mirror? Why is a convex mirror called a diverging mirror? The reason is because rays that are close and parallel to the principal axis will appear to diverge from a certain point, that is after reflection from the mirror. You say it is also called a diverging mirror. Because rays that are close and parallel to the principal, axis appears to diverge from a point called the principal focus. called the principal focus. Principal focus after reflection. After reflection. So dear learners, you can be asked, why is a convex mirror called a diverging mirror? The reason is, it is because rays that are close and parallel to the principal axis appears to diverge from a certain point called the principal focus after reflection from that curved surface or that curved mirror, and the type of the curved mirror is called the convex mirror. So now dear learners, after looking at the two types of curved mirrors, we have some terms that we need to know as we deal with reflection of light at curved surfaces. Terms that are very important for us to know as we deal with reflection of light at curved surfaces. And I said when we talk about curved surface, we take specifically the curved mirrors. So terms used in reflection. Terms used in reflection at curved surfaces. At curved surfaces. So now dear learners, for us to understand these terms, we need to consider a ray of light or rays of light falling on a curved mirror. Then we see what happens when the ray comes into contact with the curved mirror. So we are going to take, for example, when we take a concave mirror. This is a concave mirror, and we say the concave mirror has the inner surface silvered, which means the reflecting surface of a concave mirror is the inner surface. Then we shall have a line that is passing through the center of the curved mirror. So this line, we call it the principal axis. Now we shall have rays of light from an object falling on this curved mirror. There can be so many rays falling on this curved mirror. If we take a first ray that is parallel to the principal axis, so this ray is parallel and close to the principal axis. The ray is represented with a straight line with an arrow, in which the arrow shows the direction of propagation of the ray. Then if we also have another ray still close and parallel to the principal axis, so this ray will also be reflected from this curved mirror. So now we shall have a point, we call it F, and that is the principal focus of that mirror. So now these rays will be reflected. So this ray will be reflected, and it will appear to meet at a point called the principal focus. Then the second ray will also be reflected to pass through the principal focus. So dear learners, what we are going to see is that these two rays, after being reflected from the curved mirror, they converge to a certain point which is called the principal focus. So now a point which is found at the center of the mirror is called the pole of the mirror. We denote it with letter P. So this is mirror of width AB. So then this is a line called the principal axis. Principal axis. So now dear learners, after considering these rays, how they are being reflected, then we shall also have the center of this mirror. So after noticing this, it is now going to be easy for us to understand these terms that we use when we are dealing with reflection in the curved mirrors. So now the first term that we are going to look at is the center of curvature. Center of curvature. Center of curvature. So now dear learners, when we look at this illustration, we shall find that the center of curvature is denoted with letter C. So now this is the center of the sphere of which the mirror forms a part. Or in other words, we say it is the center of the sphere from which the curved mirror has been cut. Dear learners, look at this. If this is a spherical surface, then this spherical surface has its center in the middle. Then if we decide to cut a portion of this spherical surface, when we cut this, so what is going to be formed is this. This is what is formed, and this is point C, which means the center of this original sphere from which the mirror has been cut is what is called the center of curvature, and it is denoted with letter C. You say this is the center of the sphere of which the mirror forms a part. Or in other words, you can say it is the center of the sphere from which the curved mirror has been cut. Then after looking at this, dear learners, the second term that we have is the radius of curvature. Radius of curvature. So now a radius is the distance from the center of any circular figure to any other point on that circle. Still considering the sphere, the distance from the center of the sphere to any other point on the surface is what is called the radius. Now if we talk about the radius of curvature, we mean the radius of the sphere of which the curved mirror forms a part, or in other words, you say it is the radius of the sphere from which the plane mirror has been cut. So this is the radius of the sphere of which the curved mirror forms a part. That is the radius of the sphere from which the curved mirror has been cut. So dear learners, there are still other terms that are very important that we need to know as we deal with reflection in curved mirrors. So term number 3, let's look at aperture. So now dear learners, what do we understand by the term aperture as we deal with reflection in curved surfaces? So aperture refers to the width of the mirror. So looking at this illustration, we can see that the mirror starts from point A to point B. So the width from point A to point B is what is called the aperture of the mirror. So this is the width, of the curved mirror. So when you look at this, from point A to point B shows the width of the mirror. So that is the next term that we need to know. So dear learners, we have other terms still. That is term number 4. It's called pole of the mirror. So now dear learners, what do you understand by the term pole of the mirror? So looking at our illustration, we shall see that the pole is denoted by letter P, and it is found in the center point of the mirror. So we are going to say the pole is the center point of the curved mirror. The center point, this is the center point of the curved mirror, That is a point which is found in the middle of the curved mirror, and it is denoted with letter P. Then the next term, number 5, is called principal axis. So dear learners, still from this illustration, we shall find that a line that passes through the center of curvature and the pole of the mirror is what we call the principal axis. It is this line which passes through the center of curvature and the pole of the mirror. So dear learners, you're going to say this is a line through the center of curvature and the pole of the mirror. This is a line through the center of curvature of the mirror and the pole of the mirror. The pole of the mirror. Meaning the principal axis passes through the center of curvature and the pole of the mirror. So dear learners, there are still other important terms that we need to know. Next we have that is term number 6, we have focal length. Focal length. Focal length. So now dear learners, from this illustration we shall see that the distance between the principal focus F and the pole of the mirror, we denote it with the small letter F. So now this distance between the principal focus and the pole of the mirror is what is called the focal length. So we say this is the distance between the principal focus and the pole. The distance between the principal focus and the pole, we call it the focal length, and we denote it with a small letter F. So dear learners, these are not the only terms related to reflection in curved surfaces. Let's look at other terms still that we need to know as we deal with reflection of light in curved surfaces. And this curved surface, we are taking a curved mirror. We are taking a curved mirror. So the next term that we have is principal focus. That is term number 7, principal focus. Principal focus of a concave lens. A concave mirror. Principal focus of a concave mirror. So now dear learners, what do you understand by the term principal focus of a concave mirror? Looking at our illustration, we shall see that the principal focus is a point to which rays that are close and parallel to the principal axis converge after reflection from the mirror. So this is the point where these two rays are converging. So the point to which the rays converge is called the principal focus of concave mirror. So this is a point. This is a point along the principal axis. Along the principal axis, where rays that are close and parallel to the principal axis converge after reflection. So when these rays are reflected, they come and meet at a specific point, and this point where the rays will meet is called the principal focus of a concave mirror. So dear learners, the principal focus of a concave mirror is different from the principal focus of a convex mirror, because the principal focus of a concave mirror is real and the principal focus of a convex mirror is visual, meaning the rays that will be, or the image that will be formed is will be due to the apparent intersection of rays. But for a concave mirror, the rays will be formed by the actual intersection of rays, as we can see in the first illustration. Now let's look at term number 8. Term number 8 is the principal focus of convex mirror. Principal focus of convex mirror. So now, dear learners, since we said the principal focus of a convex mirror is different from the principal focus of a concave mirror, let's see how rays will be reflected from a convex mirror. And we said the convex mirror has the outer surface silvered, which means the reflecting surface is the outer surface. So taking this to be the convex mirror, this is the convex mirror, then rays will be falling on this convex mirror. So now we said a line through the center of curvature and the pole of the mirror is called the principal axis. The principal axis, that is a line through the center of curvature and the pole of the mirror. So now we have a point which is called the principal focus, F. So now rays of light will be falling on this curved surface. If we have a ray that is close and parallel to the principal axis, so this is a ray close and parallel to the principal axis. We shall also have another ray which is still close and parallel to the principal axis falling on this curved surface or the curved mirror. And this type of curved mirror is called the convex mirror. So once these rays touch this curved mirror, since it is the outer surface that is silvered, which means reflection will occur at the curved surface. So these rays will be reflected in that direction. It will be reflected in that direction. Then also this ray will also be reflected in another direction. So now, dear learners, when you have to look at where the arrow is pointing, the arrow is pointing in that direction, and it appears as if the rays are coming from a certain point on the principal axis. So when we project this line, we shall find that this line will appear to be coming from the principal focus. Then the same with that ray will also appear to be coming from that point denoted with letter F, which is the principal focus. So now after this is the pole of the mirror, P, then the distance between the pole of the mirror and the principal focus is called the focal length. We denote it with letter F, and this is the principal axis. Principal axis. Then we shall have the center of curvature. We denote it with letter C. So now, dear learners, it is from here that we are going to define what principal focus of a convex mirror is. So we shall say this is a point along the principal axis where rays that are close and parallel to the principal axis appear to diverge from after reflection from the mirror. So this is a point, along the principal axis. Along the principal axis, this is a point along the principal axis where rays that are close and parallel to the principal axis, parallel to the principal axis, appears to diverge from after reflection. So in actual sense, these rays are not coming from this point, but they just appear to be coming from this point along the principal axis. And this point where the rays appear to be coming from is called the principal focus of the convex mirror. So dear learners, the two types of curved mirrors are, one is called the concave mirror, which is also called converging mirror. Then two is the convex mirror, which is also called the diverging mirror. And we have looked at some of the terms that we need to use as we deal with reflection from this plane mirror. So dear learners, you can be asked questions. You can be asked questions in this way. So question one, what are curved surfaces? What are curved surfaces? Or you can say curved mirrors. What are curved mirrors? Then two, name the two types. Name the two types of curved mirrors. Curved mirrors. Then lastly, three, define the following terms. Define the following terms. The following terms. A, you can have center of curvature. Center of curvature. 2B, focal length. So dear learners, these are how you can be asked. What are curved mirrors? Then name the two types of curved mirrors. Define the following terms. One, you have center of curvature. Then two, focal length. So dear learners, up to this point, I hope you enjoyed the lesson. I would like to say bye-bye for now. I am teacher Akena Patrick Omon.